This recording is for my grade 12 students to demonstrate motion on a circular path of a car on a highway. In this particular problem, the car is moving in this brown curve. It's flat. There is some friction. Question usually asks what should be the coefficient of friction such that the car can safely negotiate a turn, and things that are given that could be known to us are radius, speed. Sometimes there's mass of a car that's given, but it's really not needed for the solution. So question is, what is the coefficient of friction such that the car can negotiate the turn at the velocity that will be given to us? So let's analyze this motion. This is the view from the top. Velocity is perpendicular to the radius. Centripetal acceleration is pointing to the center, and friction force is the horizontal force that keeps the car on track, is pointing towards the center. Otherwise, the car will fly off. If I look from the side, my AC is pointing to the center. This is the central rotation. Force friction pointing to the center. Gravity is pointing down. Reactions pointing up. Sometimes this N is known as Fn, but I just use N. So question is, what is mu? Let's write the second Newton's law, that the sum of all forces acting on this car equals ma, where a is the centripetal acceleration. Which forces are they? Friction, normal, mg. Equal ma, centripetal. And then what I usually do, I introduce the system of coordinates, x and y, and resolve the vector equation into its components. What's important to know that for all these questions, x should be pointing the same way as centripetal acceleration. Y can be perpendicular, pointing up, but where x is pointing is very, very important. So then I write my components for x and y. So x is pointing that way. I have acceleration, friction, and mg are not giving any components horizontally, 0 and 0. So let's see. F friction. I'll put 0 instead of normal force. I'll put 0 instead of mg. MAC. For the y components, AC is 0, friction is 0, and mg pointing different directions. Okay, friction and is positive, mg negative, that's 0. So what do we take from here? It looks like if I just simplify the first line and the second line, it looks like F friction equals MIC and normal force equals mg. This one we have seen many times. Let me just rewrite it. Sometimes it's written like Fn equals mg. By the way, what is friction force? usually coefficient on friction times normal force. And if we take normal force as equal mg, mu mg. I think we have seen this many times. So all we need to do is, instead of friction, put mu mg. At this point, we will notice that m and m's cancel each other. And mu, in fact, is AC divided by G. What is AC? I think we have everything we need for AC because centripetal acceleration is v squared divided by radius. And G. So depending on what's given, we will be able to calculate mu. Just take any numbers, reasonable velocity, imagine radius, and you know G. So you can imagine certain numbers in here and then do the calculation. What I do have to notice that for different road surface conditions, mu can be different. And it varies from 0.8 for dry asphalt, 0.6 for gravel, 0.4 for wet conditions, and 0.3 snowy conditions. So you could see that speed actually plays a big deal. It's squared, so high speed will turn this number to be big, and it's not good because on snow, we want this number to be small. So drive slowly, and we'll see you in the next question.